You're listening to Cool Air Hot Takes.
Welcome to Cool Air Hot Takes. This is a podcast about anything and everything from the building, energy, and HVAC space. We are your hosts. I'm Charlie Jelen, along with the one and only Mr. Dan Gentry. If you're new to the show, we're friends from middle school, both found our way into the heating and cooling business. We genuinely love this business, and it consumes most of our conversations in and outside of work. So we decided to start a podcast.
Every couple of weeks, we get together to bring you HVAC headlines, getting you caught up with the latest HVAC news, an expert interview, and this week we have Principal Electrical Engineer at Geronimo Power, Jason Espeseth. We're going to be talking about power generation, current bottlenecks with bringing loads online, and solutions on-site, near-site, and utility power. We're bringing back a fan favorite segment called Hot or Not.
Hot or Not.
And of course, your stat of the day. But first, it's time for some hot takes. Charlie?
I got a hot take. My hot take is if your specification does not include some type of storage option, either electrical or thermal, it's outdated.
Okay.
Every design should have something that is able to shift loads. If we think of systems, not products, but systems, as 30, 40, 50-year design criteria, I think there should be some form of storage, either on the electrical or the thermal side.
We're seeing that happen too.
It's slow. Like, this stuff isn't new. Batteries aren't new.
No.
Like thermal storage on the water side. Tanks are not new. Ice is not new.
No.
And people have been doing it. But I think that the optionality side, putting it in front of owners and explaining the future value of it. I mean, there's clearly value for it today, especially, we talked about it last time, like stuff going on PJM and on ERCOT. Demand pricing is going up.
Yep.
Energy pricing in general is going up. It is a way to both get revenue now, as well as I think it will be more valuable in the future. And if you don't have that design, if the owners do not know what's available, I think you're looking too short.
I think another part of it too is awareness. Like, it's just an ice tank or just a tank.
You love tanks.
I love tanks. Yeah,
this guy loves tanks. It's a big tank guy.
Big tanks. But I think it's just being aware of it. You know, what do the modes look like? How do you sequence it, control it, comfort, that kind of stuff. So
yep,
I like it.
What do you got?
So mine is back to the hydronic systems again, where I spend a lot of my time.
It's just going to the well. You're just going to the well.
You know, I love drinking out of the well. And this one came up because I had a project on my desk that had like 3 or 4 different kinds of units, like modular, packaged, multi-pipe, all on one big loop with one set of manifolded pumps. And it's like, man, how are you going to like control all this? I'm a big fan of dedicated pumps, decoupled systems, especially when you're starting to build these more involved.
Dedicated primary pumps.
Yes, dedicated primary pumps.
Okay.
When you're getting these more involved systems, and a lot of comments we hear is, well, we don't have enough room for pumps, so I'm going variable primary flow. It's like, that's not a reason. Just because you're like, well, I can't find a space for a pump, so I'm going to go with this pumping configuration. I don't like that. It's kind of a pet peeve of mine. And on top of that, I would make the argument you can always use just inline pumps that literally don't take up any space that's in the piping.
Yeah.
Sometimes it can be supported by it, maybe a hanger above or a little stand.
Yeah.
So it's like, I think there's better options sometimes.
Yeah, you're not doubling the space needed for pumping. If anything, it's marginal.
Yeah.
Well, maybe not. How much do you think it adds to add primary pumps? And so for the listener out there, what we're talking about, primary pumps only pump water around the chiller plant. And then those secondary pumps are what pumps all the way out into the building and through the air handlers. And so in a variable primary system, there's only one set of pumps that do all of that. In decoupled primary secondary, there's 2 sets of pumps, one for just the chiller, one for the rest of it. And so you end up with more pumps in primary secondary.
Yep.
But they're smaller.
Yep. And I think too, the footprint too. I mean, if you could be like dramatic, you know, if you got like 3,000 ton chillers, it's going to be a good size pump you're going to need anyway. So that kind of is what it is. But you go even like a 300 GPM modular chiller. I mean, that's a pretty small pump. You got some options to move them pumps around and make a good, healthy system.
All right. So at the end of the day, your hot take was?
Quit using excuses to go variable primary flow, maybe.
All right. Very good. I like it.
Up next, HVAC Headlines.
HVAC Headlines. Your news today.
All right, listener, it's 4:30 in Taipei. Here's your headlines. The U.S.'s first grid-scale sodium-ion battery is now online. And this is from Electric. Danny boy, are you dabbling at all in sodium-ion batteries?
It's on my list, but you're going to have to educate me on this.
I'll walk you through it a little bit here. So first of its kind in terms of grid scale sodium ion battery, this specific one is 3.5 megawatt hours. So in terms of size and the amount of power that it delivers, pretty big. It's serving a grid in Colorado right now. But the reason that this is important and the reason that it caught my attention is this technology, sodium ion batteries, is going up against lithium ion batteries, which we've used for many, many years. We use it for all sorts of things. It is the primary technology used for grid scale, building scale, or building electric, as well as data center UPS energy storage. So we use it all over the place, and a lot of it is going in right now. Sodium ion is potentially a better suited technology for us. When I say us, I mean the US or North America. And I'll walk you through, what do we got? 1, 2, 3, 4, 5 reasons or 5 categories why.
All right, buckle up.
Category number 1, raw material abundance. So sodium is readily available. You can even get it from seawater. Lithium is limited to a few countries. Australia is a big one. There's a few countries in South America. But in terms of in the US, we have very little of it. If you look at the battery pack itself and you look at energy density, lithium is higher. If you think of like an average amount of energy density, they measure it in watt hours per kilogram. So energy per weight, let's say it's 225, sodium comes in at 125. So this
means you need a larger pack.
Right. Yep. You need more of whatever material or whatever battery pack to get the same amount as lithium. And so that's primarily why lithium's been the dominant technology here, because it packs a bigger punch. But you go down to the next one, cost. Sodium has a lower projected manufacturing battery cost due to primarily the materials.
Abundance.
Lithium becomes really expensive and sodium is way, way cheaper. So the base materials, and then if you start to look at, and I don't know battery technology all that well, but like the anode and the cathode material, it becomes lower cost overall. Safety. So there's the pack cost, like just the battery itself, but then there's also like the system cost associated with it. And a big component of driving the cost up on the lithium side is there's this risk of thermal runaway. So you've heard of like meltdown of battery packs. There's a max ambient temperature limit that lithium runs at. So you need cooling systems. You need fans and heat exchangers to pull that heat away. Sodium doesn't need that. It operates at a much higher and a much lower temperature. So like the system costs are actually lower.
Yeah, makes sense.
So if you talk about total cost of ownership, it's projected that with variability in supply chain or volatility in supply chain for things that we don't have abundant access to, the projected cost of sodium ion batteries is lower than the projected cost for lithium ion batteries for grid scale applications or data center applications. So that's why it's interesting. First one's going in and we'll see how it goes.
So based on that, it looks like we should probably see more of those.
I think so. Yeah. It's one of those things, like if we're going to start using more electric batteries and we're trying to onshore a lot of that production, it makes sense that we're going to start to try to build things that we have easy access to the submaterials.
Well, and that's kind of one of the whole bangs against all this stuff, batteries and renewables, is the materials that go into them. And if we have an abundant, easily to handle material, that's a good idea.
All right, up next, we have the principal electrical engineer from Geronimo Power, Jason Espeseth. Don't go anywhere.
Is your data center performance being held back by outdated HVAC solutions?
Trane can help you break those boundaries. Innovating for engineers, contractors, and facility managers every day, Trane delivers mission-critical solutions with a full portfolio made for the unique challenges of your environment.
Forget the what-ifs. Embrace reliability and efficiency. Experience next-level data center results. Check out Trane Data Center Solutions and say goodbye to downtime.
All right, welcome to Cool Air Hot Takes, Jason Espeseth. How you doing today?
Doing pretty well. How you guys doing?
Very good.
I'm doing great. It is very nice out. All right, so by way of a multiple choice question, by the way, this is a first for Cool Air Hot Takes. We're going to attempt to introduce you to our audience here. So here's the question.
Okay.
If you're at a bar and your buddy gets into a little scuffle, a little confrontation, how would you help diffuse the situation? Option A, get in between your buddy and the other guy or gal. Option B, grab your buddy and get him out of there. Option C, jump up and down as high as you can in order to distract everyone and diffuse the situation.
I'm going to go with option C on that one, Charlie.
All right, very good.
Sounds like a story.
Well, it's loud in bars, and my buddy's not real big and intimidating size-wise, and the guy that was sizing him up was real big. And so we thought, let's jump up and down. I don't know why, but it sounded like a great idea at the time. So that's what I did.
Did it work?
Yeah, it did. They were like, he's crazy. Let's get away from him. Like, yeah.
So, listener out there, I know Jason's wife pretty well. And so I asked, give me a little background. And that was the first story she pulled out. And I was like, that's perfect. That's great. But what I think it highlights for the listener and our guest today is that we have a unique problem solver on our hands. And I think that's what you're doing with Geronimo Power. So we're going to get into that. But first, name of the show is Cool Air Hot Takes. We asked all of our guests to come on with a hot take, personal life, professional life, anything in between. What do you got for a hot take today?
Yeah, I'm going to go professional here. And in the data center industry, there has to be generation brought to the table. And I might be a little bit biased because that's what we do, but there's not enough generation out there. And everyone wants to go big. Everyone wants to go now, but they have no means to do it. So I don't know if it's really a hot take, but data centers should bring their own generation.
I like it. I'd call it a hot take, especially if you would have said it 2 years ago. Nobody would have believed you.
Yeah.
Now it feels like it's more the way that we're going. We had Sam Brown on from Server Farm a couple episodes ago. They're a data center developer, and he absolutely was kind of in lockstep with that. So let's start a little bit back here. What is Geronimo Power, and what do you do for them?
So Geronimo Power is a renewable developer kind of at heart, but fairly recently, let's say in the last 2 years, we started getting into the data center industry, trying to match renewable generation with data centers. And we've started also to get the natural gas side to firm up renewables, to use it as a way to get that constant power. But think of it more like an energy campus. So the renewables can be helping, wind and solar and batteries can help a ton. They can do a large portion of the needs of the data center, but at the same time, you need a little bit of gas capacity. So whether it's the system that has available gas capacity or we bring our own gas capacity, it's trying to facilitate that. So even though we're typically a renewable developer all throughout the country, have multiple gigs in the ground, we're trying to now use the generation resources and the abilities we have to dictate how the data centers can be most effectively implemented around the country. How
much renewable energy can you legitimately bring into a data center campus? Because I think of the projects that we're working on now, 100 megawatt plus up to gigawatt or even more. And I think about typical renewable in my mind is solar, is wind, and having enough space for that on site seems daunting to go after that. So how are you guys going after the space? It doesn't necessarily mean to be on site. Renewable generation typically is sited and then there's a gen tie. So you can have a 20-mile gen tie and not be a big deal. So locating generation in the right locations, windy, solar can go most places, but wind is a key component of that. And we also don't even need the absolute best wind out there. The technology nowadays is good enough that you can put it in the little less desirable places than it used to be. At the same time, you gotta get that to a data center location. So we're mostly targeting places that are a little bit outside of the typical major metro areas, that tier 1 data center. Mm-hmm. It's a little bit further out, but still not saying that we're in the middle of nowhere kind of thing. Yeah, I've heard the term near site. So on site being on site, like physically co-located. Near site, is that what you're talking about? Like you can near site something where there's physics? Is there still physical cables, or is this more of like a virtual power purchase agreement where there's generation somewhere? No, not necessarily. It's not like a VPPA is not what we're targeting. It's more like a co-location, but the gen tie exists. What is a gen tie?
So a gen tie, think of it, you build a wind farm, you kind of collect it all one spot, and then you need to bring it to where you need to connect to the system. So that connection from the collector where all the wind connects to where the system interconnection is called a gen tie.
So in your model for renewable powering a data center, how physically close are they?
Yeah, I mean, you can go pretty far. You do drop reliability the further out you go, right? There's more exposure on the line.
Mm-hmm.
But in general, we're staying 20 miles or something like that is kind of the furthest we're going.
What's like a typical split that you see? Let's take a 100 megawatt data center. Like how much renewable versus natural gas are you able to get to?
Everything's a little case by case basis. My team works on that, and my colleague would say probably like 70% renewable.
Okay.
Oh, wow.
And you can do the rest with natural gas. So we can do a lot of it. It's just not every bit of it.
That's impressive. That's a really high number. I feel like a lot of people don't understand that. They just think, oh, they need all this power and it's dirty or whatever. But that's a significant piece.
Yeah, I mean, it uses batteries a fair amount. We install a lot of batteries just to try to help smooth that out.
Do they firm it up so that you can actually use it for peak capacity?
Absolutely.
Yeah. Okay.
Yep.
In a normal application, is it kind of a threefold? Like you've got your renewable component, you've got a near site or on site natural gas component plus. Do you have a utility feed as well?
Yeah. So we use the utility feed most of the time, and I'll get a case by case basis. But that utility feed is very helpful in a lot of different ways. But it helps from a system stability standpoint, and using that from a frequency connection, it just makes everything just easier.
When a client comes to you and you guys are working, what are the biggest challenges that you guys have to get over when you start to look at bringing multiple sources to the table versus them just going to the utility and essentially getting one plug?
Yeah, I mean, if you think about it from the standpoint of the utility, right, let's just take a step back. If you take the utility's viewpoint, they're doing the same thing. They're getting multiple sources together to combine it to the system, and then they have to get it to the customer. So there's actually a lot more build out that needs to happen typically before it can actually get to the customer. So that connection, let's say you have to build it. Maybe you do wind, maybe you do solar. A lot of states have renewable mandates. So large quantities need to be renewable and solar. If you take that and then have to connect it to the customer, they're nowhere near each other typically. And now you have to build large transmission lines to get there. That takes time. It takes a lot of money, but mostly time. And that time is a major hurdle. It's speed to market in general in the data center industry, right? So having to rely on a large transmission build out is not going to help with that speed to market. So if you think about it from that standpoint, bringing generation that is planned already, nearby, has a line of sight, that can help speed the connection up significantly. Hopefully I answered that question.
Yeah, that makes a ton of sense. Looking forward a little bit, like what else is out there that you guys are starting to look at? I think of fuel cells. I think small modular reactors are like everybody's favorite topic of conversation, at least in my house. What are those like next generation things you guys are starting to play around with?
Like you said, everyone's favorite small modular reactors are kind of the ideal choice for data center. They can go anywhere.
Yeah.
Get a little bit of water, you're good to go. But that technology is out there a little ways.
Yeah.
Part of the beauty of the campus approach that we're talking about, though, is that you can put a small modular reactor there in the near future or in the future when they become viable, and then it just ties into the rest of the campus. Nothing changes for the end user.
It's a nice solution.
Yeah.
It doesn't mean it completely replaces it, but having it tied into the rest of the campus so you have renewable generation, and it basically takes out the natural gas, right? So you have renewable generation and batteries, and those two are really smoothing out any of the ripples. But the small modular reactor is just sitting there and running.
Yeah. Give me your ideal scenario. Let's say it's a 1 gigawatt AI campus.
Okay.
Let's say it's not Loudoun County, right? It's not like in a super dense populated area. Let's say it's a little further out, and you've got a little bit of land, which is pretty common right now. Like a lot of the larger data centers that are going in are not in the middle of a massive city or in the middle of a massive build out. What's the ideal solution?
Boy, ideal solution. I still think there's a really great ideal solution with wind. Solar is great, don't get me wrong, but you get a lot of extra capacity, a lot more out of wind in general. So I would say use wind, have a natural gas line nearby that is very large. Use those two and batteries. If it's a nice area for solar, great, But otherwise, ideally, it would be wind, natural gas, and battery.
What's the splits? Like, is it 50% of the demand peak is from wind, 25% from battery, and then another 25 from the grid? Or
I mean, the hardest part with this whole thing is trying to say, well, where can the grid fall into here, right?
Mhm.
So I like to not rely on the grid in my ideal scenario,
okay,
but it would not be an islanded solution. It would be relying on the grid for things like stability and frequency, but generation is
minimize
provided.
it for speed and interconnection.
Well, yeah, it would be minimizing everything from an interconnection standpoint because that's super slow right now, and also impact the customers. You know, the non-data center ratepayers that are out there. You see that around the country already, and it's kind of a hot topic, especially in the East. But Pennsylvania is very much aware of it and bringing that up. So we're trying not to have to utilize a system in the middle and just put it on site. So ideally, you would essentially make it a wash the customer sees. The end user pays all the bills, not the everyday Charlie and Dan.
That's nice.
If we ask this question a lot from the people that come on the show, is if you had a magic wand, what's the one thing you would change in your industry?
That's a heck of a question. If everyone was willing to work together, all utilities, all data centers, all developers, that approach takes out the corporate nature of it, but it makes interconnections work a lot better. Highly unrealistic.
Yeah. I don't think the average person has like an appreciation for the interconnection side of this. Like, what does that process actually look like? It is months, years, how much time, how much effort? Like, I know every interconnection is different, but.
So it depends on where you are. Texas is mostly ERCOT, and ERCOT is a little bit different. The speed to market's a little bit faster, but the saturation is pretty high in the desirable areas. So places like Dallas, Fort Worth are just swamped with interconnections, and you're not going to get online for another 5 to 10 years. It's the reality that they're in just because of the sheer number that they have.
Yeah.
But otherwise, around the country, if you're in Northern Virginia, you're going to be there for a while. But if you pick a little bit more realistic areas that are a little less tapped out already, it's still going to take a couple of years, though. It's not an easy process. It's very involved. The difference in generation and load is significant. People think about generation, they just bring it online. It doesn't have to be there all the time. It's as available. But when you talk about a load, that load has to be online. So thinking about it from that standpoint, there's a lot of redundancy. There's a lot of reliability. There's standards that are associated with it that are much more robust than generation standards. The federal government has oversight into this, FERC and NERC. Those are requiring generation to help serve this. It needs to be there, but the load has to stay online. The only other way to do it is to have load come online and then be willing to drop under certain conditions. And no data center is willing to do that.
Do you guys work with demand response providers on trying to manage some of that?
I did in a former life in my previous job, but not in the current one. I mean, it'll be part of it. Any data center is going to be asked to do some portion of it. It's a matter of how much and how they respond to it. So if it's a major system event, the operator in the area might say, we need you to turn on backup generation or shift your power to some other location.
Yeah.
And sometimes that's possible. Multiple campuses work together. You can shift load. Think of it like load. You can shift that load, that traffic, to a different one in a different state that might have availability at the time. Or you turn on backup generation. You need to run it sometimes anyway just to make sure it runs. Those few hours of the year when the system really needs it, you could turn it on. And then the system sees a lot less impact. But there are some companies out there, and I won't say names, that are considering it for sure from what can we do to help this actually work with the rest of the system.
All right, Jason, thank you so much for coming on the show today. That was a fun conversation.
All right, thanks, guys. Appreciate it.
Hey there, listener. A higher building IQ is a no-brainer, right?
Oh, you betcha.
AI Control from Trane is smarter control that optimizes building performance 24 hours a day, 7 days a week, without the need for additional hardware or staffing.
So you can focus less on the little things and more on those most critical.
Bingo. Go to trane.com/autonomous controls to find out more about Trane's latest AI offering.
All right, listener, welcome back. We are bringing back Hot or Not.
Hot or Not. Here we go.
Data Center Edition. We're going to throw this over to our producer, Elena, who is going to be kicking off questions for us.
Yes. Hi, guys. Thank you for having me back. I think this is my second appearance.
Welcome back. I think a lot of our listeners have been asking for you more. So here we go, listener. This is what you wanted.
Hashtag where's Elena?
Yeah, exactly. I love it.
Okay, well, I'm honored. I'm honored to be back. So today we're going to do another edition of Is It Hot or Is It Not? And here's how it's going to work. I'm going to throw out a few trends or ideas in the data center space today. And you are going to tell me whether you are hot or not on these. So hot being yes, 100%, these are the future, and not being no way. Make sense?
Makes sense. Mm-hmm. Let's do it.
Okay, cool. And I should say, if you want to catch the full video of this, make sure to search for Cool Air Hot Takes on YouTube, and the full video will be on there. The podcast is kind of getting like a little bit of like a highlights, best bits. So if you want the full video, head to YouTube. That's where it'll be. So statement number 1, microgrids are the future of data centers. Are you hot or not?
I think microgrids are the future of data centers for a very short time. I don't think it's going to be long-term. I think this bring your own power to data center trend is not necessarily going to be short-lived in terms of like people aren't going to do it. But I think the reason that we're doing it now is because we can't get power fast enough. I think in the future, we are going to have enough power to power these. I think data center developers would prefer to have the utility grid on board and use the utility grid. So I think in the short run, yes. Long run, not. So hot, short, long, not.
I'm going to concur because I was going to say it's obviously critical for the short term, but to your point exactly, once the power infrastructure is built out, and we've talked about other topics on the show like distributed energy and interconnecting and all this kind of interesting stuff, there's going to be different solutions moving into the future. So yeah, it's hot for now and eventually it'll change.
Okay, that's two very non-committal answers there.
I thought I was very committal on it.
I would say it sounds like you're maybe tepid, lukewarm on the idea as an in-between.
It's a good short-term solution.
Okay, hot on the short-term solution. Okay, I'll accept it. Trend number 2. Data centers are the new monuments of our time. Are we hot?
Yes. I like it.
Yes. This is a great question. This is a great question.
Who's going first? I'm excited.
Are we hot or
this
not?
Well, so listener, this one came back from the Jelen Gentry family trip to St. Louis this year. We're looking at the arch, standing underneath it, very, very cool structure. And Dan was like, man, we don't build anything like this anymore. And my response was, man, I think we are. I just think we don't see them like this. They're not showy. They're, data centers are the new monuments of our time. So that's where this came from. So I'm hot on this. I think they are not necessarily like the same. We're building them for the same reason. I think we build monuments in the past, Mount Rushmore and the Arch and all these different things.
Empire State Building, these beautiful things we see. And
yes, tangible. Exactly.
Yeah.
It's like the massive amount of money and infrastructure and resource that's going into data centers is monument building-esque.
It's monumental?
It's monumental. It's monumental. That's good. Good catch. So I would say, yeah.
I agree. I remember standing under the arch thinking about that. In my opinion, why I think they are monuments is because like to appreciate the engineering that goes into these things, the engineering for like the chipsets themselves and like the AI, like everything that went into like developing and designing, engineering, all that. It's an engineering marvel, I think, if you will. So it's not like, oh, cool, let's go look at this pretty data center, but we can appreciate all the efforts that went into it and all the technology that's in there. And then all of the output that we're getting from all this technology, all this AI modeling and all this stuff. It's like, it is monumental.
Yeah. Don't get me wrong. I would love more monuments, though.
Yeah, I mean, we
Big
agree on
monument
this.
guy.
I'm hot on monuments.
Yeah, hot on monuments in general. We need more monuments.
Yes, bring them back.
Okay, nice. So we're hot on monuments, but we're also hot on data centers as monuments of our time. So thank you guys for indulging me
Thank you.
Another edition of Are We Hot or Not on this. I'm curious to know if our listeners agree or disagree with any of those statements. So I would love it if anyone could send us an email at coolair.hottakes@train.com Or you can, of course, leave us a comment on whichever platform you're listening to this on. And remember, you can watch an extended cut of this feature on YouTube. Just search for Cool Air Hot Takes and you'll find us there. And I think I'm going to do it. Up next, stat of the day.
Yeah, there you go.
Here comes your stat of the day.
Stat of the day. Stat of the day. All right, listeners, stat of the day time. This is ranking the top 15 countries by primary energy consumption per capita. So who uses the most energy at a country level? So this is in gigajoules for the year of 2024. That is the metric.
So in my mind, I went straight to the Middle East because it's hot and they need a lot of air conditioning. And I'm assuming they consume a lot of power.
Okay.
So Saudi Arabia's got to be high on that list. And then like Qatar and like UAE. And then there's probably some like outlier that I'm not sure of that's on there. But I was going to take a stab at those three. They got to be the highest. I can't think of outside of that. I don't know. Is it the United States or something like that comes in after that? But that's kind of where my mind was thinking. And unless there's some cold place that has a ton of heating and uses a ton of power, but I'm going with Middle Eastern countries. It's got to be towards the top. There's a lot of air conditioning there.
Yeah. All right, let me run through this. So top 10, we're going to start at number 10. Number 10, the U.S.
Oh, okay. 10. All right.
265 gigajoules per capita. Number 9, Canada.
Canada.
297. Oman, 302.
There we go. I'm getting close.
Saudi Arabia, 347.
Go.
There you go. Trinidad and Tobago, 381. Kuwait, 383. Yeah. There's a big jump in here. So remember, US 265 at number 10, number 5 Kuwait at 383, and then it jumps to the UAE at 496.
Oh, UAE, yes. Look at me guessing.
All right. One area of the world that you didn't go to right away was Singapore.
Oh, that's super, super, super dense.
Yeah, exactly.
Yeah, it's hot. Yeah.
I don't know if I would have come out with that one.
I actually did a bunch of chiller plant jobs over there back in the day.
Yeah, there are a ton. Well, in manufacturing too. 650.
That's a
650. The US is at 265.
Wow.
Singapore 650. Above that, you nailed this one, Qatar.
Yeah.
768. All right, but they all pale in comparison to number 1, Iceland.
I did not see that coming. I mentioned a cold place, but I still don't know if I could fully explain that. What are they using all that? Why is that?
Well, I think one of the things that I'm seeing here is island nations are primarily a lot of these. So I think part of it is power production and how they get their power. Wow. So if they need, liquefied natural gas on ships to get there to burn, like I think if all of that goes into it, that could be part of it. That's my guess.
That was a good one. That was fun.
Stat of the day.
Nice.
All right. Thanks for listening to this episode of Cool Air Hot Takes. Thank you so much to Jason from Geronimo Power for joining us today. Send us your questions. We want to hear your hot takes. Leave us a comment on Spotify or YouTube. Leave us a review on Apple or drop us a message at coolair.hottakes@train.com.
Remember, we could be sending you some merch for some of those hot takes. Keep them coming. Don't forget, you can leave us a rating wherever you listen. Of course, 5 stars only, folks, right? Until next time, stay cool and keep those takes hot.